Welcome back everyone, Houston Math Prep here with another integration by parts example video. We're using our system called Lipit to decide how to choose U. If you haven't seen that video, check out our video on Lipit and how to choose U when doing integration by parts. Over here, I've got my last basic example that I'm going to do in these videos. I've got an x squared times a cosine 2x, basic product rule using integration by parts. So we've got a polynomial and we've got a standard trig function here. So I've got a p and a t in my Lipit. P comes before t in Lipit, so we will choose the polynomial to be the u when we're assigning u and dv for our formula for integration by parts. So we'll go ahead and say that u is x squared and dv is the cosine 2x dx. Remember that dx is always a part of dv. Okay, if u is x squared, then du, the derivative of that, would be 2x dx. And if dv is cosine of 2x, then v is 1/2 sine of 2x. If it was the derivative of cosine 2x, a 2 would come out. Since the antiderivative is just a constant multiple, the reciprocal comes out, which is 1/2. Okay, we'll go ahead and do our uv minus integral v du. So this integral equals u times v, which is 1/2 x squared sine of 2x minus the integral of v du. You'll notice in v and du I have a half outside and I have a 2 outside, so a half and 2 were reduced to 1. So really we're just taking the integral of x times sine of 2x dx. When you do integration by parts and you get to minus integral v du, you'll always be left with some decision to make. You'll look at another integral that was probably not the original integral you started with, and you'll have to say, okay, how do I do this? Maybe it's a u substitution. Maybe it's just a definition. Maybe you have to split some things up and do some things, right? In this example here, we have integral of x times sine 2x dx. This is not a definition, we probably know, and I can't do it by u substitution because the derivative of the inside is just a constant, and it wouldn't really work out. Since this is a product and we can't really see any other way to do this, then we would need to do this by parts again, and that is certainly something that happens. You may integrate by parts, and your minus integral v du is something that must be integrated by parts again. Okay, so using our Lipit again to choose u, I have a polynomial again, and I have a trig function. And if I look at Lipet, then again my polynomial is going to come before my trig function, p before t there. So this is going to be my u, and this part will be dv. All right, let's go ahead and write down what we have, and then we'll work out this remaining by parts here. So I have a 1/2 x squared sine of 2x, and that's going to be part of my solution. And I'm going to go ahead and put minus, and then I'm going to start some brackets, and just note that this entire integral is going to go inside of that eventually. Okay, let's go ahead and do our u and dv and choose everything. So u is x and dv is sine 2x dx. If we do that, then the derivative of u is du, which is 1 dx, or just dx. And the antiderivative of dv, so the antiderivative of sine is negative cosine, and since there's a 2 in there, reciprocal would come out a 1/2, so we'll get negative 1/2 cosine of 2x. Now we'll go ahead and plug that into our uv minus integral v du. We'll put that over here. So uv would be negative 1/2 x times cosine of 2x. All right, minus integral of v du. So v du, I have another negative 1/2 there, cosine 2x dx. All right, so we've got all of that. I'm going to need to do some distributing. And then we need to do our final integral still. So minus a negative would be plus 1/2 x cosine of 2x. And then I have minus, this actually minus negative here would be plus, and then distribute the minus from there. So that's going to be a minus again. I'll go ahead and bump the 1/2 out front though, if that's okay with everybody. I'm virtually asking your permission at this moment. Hopefully you gave it. Okay, so we have this last little integral to do with just cosine of 2x. All right, so let's copy down 1/2 x squared sine of 2x plus 1/2 x cosine of 2x. And if I do the antiderivative of cosine, that will be sine. And since I'm doing antiderivative, reciprocal of 2 will come out. I already have a 1/2, so when another 1/2 comes out, that'll give me a 1/4 there. Instead, the antiderivative of cosine would be sine, and so we'll have minus 1/4 sine 2x for our final term before the constant of integration there. Okay, so that is an example of repeated integration by parts. We have something that can help you out with that called the tabular method for integration by parts. You might want to check that out in our following videos right after this in the series. Good luck with your integration by parts. We'll see you in the next one.